So children, today we will discuss about Mendeleev's periodic table. Mendeleev's periodic table. Very, very important question, children. 3 marks question also you get. Okay. So in this Mendeleev's periodic table, we will discuss about his law and what are the properties or characteristics of his table and what are the advantages and what are the limitations or disadvantages of the same. 4 points we discuss, children. Very, very important. Mendeleev's periodic table. Okay, I hope everyone are concentrating, children. First, Mendeleev's periodic law. I will say, what is Mendeleev's periodic law? He said that physical and chemical properties of elements are physical and chemical properties of elements are periodic functions of the atomic weight. Oh, not so. Physical and chemical properties of the elements are periodic functions of their atomic weight. Means what? He said all the physical properties of elements, all the chemical properties of the elements, he said depends upon atomic weight. Okay, children? Even though he is the best and the most intelligent scientist on the earth, children, and because it was somewhere in the 18th and 19th century, it was before discovery of so many elements, he said this is the only mistake he did. Atomic weight. In spite of doing this mistake, he could classify many elements, almost 63 elements, whatever are available during his period. He classified 63 elements. He classified during this period. 63 are only there. All elements he classified, and also it was almost correct. Almost correct. 90% it was correct, but this was the mistake he did. Okay, how that is the mistake, I will let you know, children. First you listen. So law, one more question. Mendeleev's periodic law. What is Mendeleev's periodic law? All the physical properties and all the chemical properties of the elements, he said, depends upon atomic weight. How it is mistake, I will let you know. First, let me tell the characteristics of his table. He classified 63 elements. He classified 63 elements, and in his table, 8 groups are there. What are groups? Vertical rows are called groups. Vertical rows are called groups. And in his table, 6 periods are there. In his table, 6 periods are there. Periods means horizontal. Periods means horizontal. Okay, children. And also, please unmute yourself. Mute yourself. Okay, 8 groups are there and 6 periods are there. And he kept elements in increasing order of their atomic weights. He kept elements in increasing order of their atomic weight. He kept elements in increasing order of their atomic weight. And last one is last criteria is and he kept all elements having. He kept very, very important, this two especially. He kept all elements having same all elements having same formula of oxide and hydrides in one group. Okay, children. So what is the meaning of that? I will tell you. Don't worry, children. First, you see what are the characteristics of his table. 63 elements are there, 8 groups are there, 6 periods are there. He arranged the elements in increasing order of their atomic weights, and he kept all the elements having same formula of oxides and hydrides in one group. Okay, children. And here you don't require any explanation. 63 elements were there during this time. He kept in how many groups he kept? In 8 groups he kept. How many periods he kept? 8 periods. Means like this table, like this it will be, no? So like this 8 are there, and like this 6 are there. Okay, and he arranged elements in increasing order of their atomic weight, like this. He arranged elements in increasing order of their atomic weight, and he kept all the elements having same formula of oxides and hydrides in one group. What does that mean? That is very important. He kept all the elements having same formula of oxides and hydrides in one group. What does it mean? It means, one example I'm giving, children. Suppose if you take first group. Suppose if you take first group, you will have lithium, sodium, potassium, rubidium, cesium, francium. Of course, francium is a radioactive element, you should not consider. What is the formula of lithium oxide? Li2O. Sodium oxide, Na2O. Potassium oxide, K2O. Rubidium oxide, Rb2O. Cesium oxide, CH2O. All of them have same general formula R2O. So whatever have all the same formula, he kept in one group. He thought that they all will have same properties. Yes, it is true, correct only. He kept like that only. Those who didn't understand, again I'm saying, those who didn't understand, please listen, children. I'm explaining again, children. Okay. Suppose second group if you take, beryllium is there, magnesium is there, calcium is there, strontium is there, barium is there, radium is there. Okay. What is the beryllium oxide formula? BeO. What is the magnesium oxide? MgO, CaO, SRO, BaO. Of course, radium is a radioactive element. You should not consider. All of them have same formula. What is the same formula? RO. So elements having same formula of oxides or hydrides are kept in one group. Then what is hydrides that you may get? Hydrides means also same, children. If you take first group elements hydrides, what is their formula? LiH, lithium hydride, sodium hydride, potassium hydride, rubidium hydride, cesium hydride. Okay, same formula they have, no general formula. So elements having same general formula are kept in one group. Because during his days, much experimental apparatus, all those things are not there, children. Whatever available, his knowledge he classified, and children, he is exceptional person. Because why he is so much exceptional, I will tell you when I'm saying advantages. Okay, so these are the Mendeleev's law, children. Mendeleev's law, very important. One mark question. Clearly, they are asking define Mendeleev's law. What are the characteristics? Characteristics means 5 characteristics you should ask. And apart from this, the most important every year, this year in 2020 also March they asked one question. What are the 2 criteria used in Mendeleev's classification? These are the 2 criteria. What are the 2 criteria? One is he arranged elements in increasing order of their atomic weight, and other one is he kept all elements having same formula of oxides and hydrides in one group. You have to learn this perfectly. He kept elements having same formula of oxides or hydrides in one group. He kept elements having same formula of oxides and hydrides in one group. So this is the law. These are the properties. These 2 are criteria. This is the law. These 5 are characteristics of his table, and these 2 are the criteria of his classification. First criteria, he arranged elements in increasing order of their atomic weight. What is second criteria? He kept elements having same formula of oxides and hydrides in one. Now coming, children, advantages and disadvantages. Very important. Advantages and disadvantages also very important. What are the advantages? What are the advantages? So children, first I told about law. I told completed. Okay, I said that physical and chemical properties of elements depends upon atomic weight. I said. And characteristics. How many characteristics I told children? 5. 63 elements are there, 8 groups are there, 6 periods are there. He arranged elements in increasing order of their atomic weights, I said, and elements having same formula of oxides and hydrides are kept in one group, I said. Kept in one group, I said. It is characteristics. And these 2 are called criteria. These 2 are called criteria. What are the 2 criteria? You should write these 2 points only. Many times in board exam they asked. Now, children, the most important topic, advantages. What are the advantages of this table? Children, what are the advantages of this table, children? Number 1, you should write number 1, this only always. He left gaps for the elements to be, he left gas for the elements to be discovered in the future. Understood, children? You can understand his greatness. Children, what is available only he didn't classify. What is not available also he classified. And like that, he left 3 gaps, children. Eka boron, compulsory you should mention that. Eka aluminium, compulsory you should mention. What is Eka, I will tell you. And Eka silicon. Eka silicon means under boron he left 1 gap, children. In table, under boron he left 1 gap. He said Eka boron because he don't know. He said in the future, 1 element will be discovered under boron, which will be having so properties, everything he told. He told about this element, everything, but he don't know what is that element because during his time, that element is not yet discovered. And under aluminium, he left 1 gap. Under silicon, one gap. You understood, children? Before you take your birth only, if someone say in the future this person is going to take birth, he will be having so characteristics, he will be of so height, he will be of so texture, he will be of so much intelligence, all your properties before your birth only, if someone says how much great. In the same way, even our Mendeleev also, before discovery of these elements, because during his time, these 3 elements are not there. What are the 3 elements? Eka boron. Eka boron later discovered as after his death, he is no more. It was discovered as scandium. Eka aluminium in the future, it was discovered as gallium. Okay, and Eka silicon was discovered as germanium. You understood, children? You understood? Yesterday I was talking about Newland. What Newland said, children? There are 56 elements. That's all in the future. Also, no more new elements will be discovered in the future. He said. Who said? Newland. That was so funny. And this man, he said, not only this, in the future, these elements will be discovered. He said, see his greatness. That is the greatness of this scientist. Are you able to understand, children? What Newland said, 56 are only there. No more elements will be discovered in the future. Newland said. But what Mendeleev is saying, no, in the future also so many elements will be discovered, and he left even gaps also. That much great. You please put, if you discover these elements, you please put here under boron he left one gap, under aluminium he left one gap, under silicon he left one gap. See the greatness. That is the greatness of that scientist. Before the discovery only, he told everything about that element, properties, texture, chemical properties, physical, everything. But he don't know the element because it was not yet discovered during his time. So you compulsory should write this only. He left gaps for the elements to be discovered in the future. They are eka boron, scandium, eka aluminium, gallium, eka silicon, germanium. Just if you write this, it is not enough, children. You should write this both also. Boron, scandium, gal, silicon, germanium. Remember, children, compulsory. One mark also. So many times in board exam they ask, what is eka boron? One mark question. Scandium. What is eka aluminium? Gallium. What is eka silicon? Germanium. Eka means below boron. Eka means below aluminium. He left one gap. Box was left empty in his table. Why he left empty? Because he said in the future they will be discovered. Okay. Number two, children. He also left gaps for the noble gases. Noble gases were not there in his time, children. Noble gases were not there in his time. He left gaps for noble gases. He left gaps for the noble gases also. He left gaps for the noble gases. Once they were discovered, they could easily adjust in his table. What are the noble gases? Actually, present day noble gases are helium, neon, argon, krypton, xenon, radon. During his time, they were not there. But how he adjusted his table means if they were discovered, they can be placed easily. Like that, he identified. And number three, he predicted properties of elements. He predicted properties of elements. He predicted properties of elements basing on their position. Some properties, children, because during his time, much of the experimental apparatus, all this laboratory, so much technological sophistication is not there. So whatever is available during his time, with that by position, he predicted the properties. Like suppose, children, sodium, lithium, sodium, potassium, rubidium, cesium, francium. Okay, children, he know this all properties, but he could not find the property of potassium because of some difficulty. He said potassium also will have same properties of this element. Simple. Basing on its position in this, he said he predicted the properties of potassium. Are you able to understand? Suppose one more example: beryllium, magnesium, calcium, strontium, barium, radium. He know all the properties, but he don't know radium properties. He said radium also will have same properties. How? He said basing on its position. He said. So he predicted properties of elements basing on their position. Whatever statement I say, children, you have to just recollect 3 times that statement in your brain. Then only you will understand. He predicted properties of elements basing on their position. So these are the 3 famous advantages of Mendeleev. What are the 3 famous advantages? He left gaps for the elements to be discovered in the future. Eka boron, scandium. Eka aluminium, gallium. Eka silicon, germanium. He left gaps for the noble gases also. And number 3, he predicted properties of elements based on their position. Instead of he left gaps, we can say like this also. Noble gases found place in his table. We can say like this also. You say like this. Noble gases found place in his table. You better write like this. Because when they identified noble gases, they could easily adjust in his table. These are the advantages. Now coming to last one, children, limitations. Very, very important, children. Okay, try to understand limitations. Children, 3 limitations are there, children. Number 1, okay. Number 1, please see here, children. I hope everyone are able to understand, children. Try to understand, put some interest, then you will understand, children. So law we discussed, children, and the characteristics, how many I told? 5. In that 2 are criteria, children. And advantages, how many I told, children? 3 advantages. 3 advantages. What are the 3 advantages? He left gaps and noble gases found the place. He predicted the properties of elements based on their position. Okay. What you studied, you should know from lecture. And last one, limitations or disadvantages. What are the limitations? Number one limitation. This only you should write. Whatever you want, you can't write, children. Whatever I am giving, like that order you should write. Inversion of atomic weights. Don't write short forms in exam. Occurred. Inversion of atomic weights occurred at some places. Inversion of atomic weight occurred at some places. Okay. In which places? Argon and potassium, cobalt and nickel, tellurium and iodine. You should mention the positions also. Simply, if you say inversion of atomic weights occurred at some places, means they won't accept. Okay, what does it mean? I will explain. Please listen carefully. Slowly, I'm saying. Try to understand. What was this law? He arranged elements in increasing order of their atomic weight. Please try to understand. Everyone, try to understand. Full concentration here on. Children, you all are in 10th class. You all are in 10th class. Your age will be 15 years. All 15-year students, 10th class means it's good. Try to understand, children. All 15-year students, 10th class means good. But if I say approximately your weight is 50 kg, imagine just, it may be different. All 50 kg students in 10th class means how it will be. I can't say like that. But he said like that. He arranged elements in increasing order of their atomic weight. He did like that. That's why it became. Maybe all maybe around 45 and 50. It's true. But I can't say all 50 kg students in 10th class only. I can't say like that. All 40 kg student in 9th class, all 30 kg student in 8th class, all 50 kg student in 10th class. If I say, how does it look? He arranged elements like that only, children. He arranged elements in increasing order of their atomic weight. If I say all 13-year students 8th class, all 14-year students 9th class, all 15-year students 10th class, means good meaning is there. Perfect meaning. It is correct. But if I say all 40 kg students 9th class, all 30 kg students 8th class, all 50 kg students 10th class, means sometime a 9th class fellow may be 50 kg. Then you will keep in 10th class. Huh? Sometime a 10th class student may be in a 10th class student may be in a 10th class student may be having 30 kg only. Then you will keep in 8th class. Huh? What is this? There is no meaning in this. There is no meaning in this arrangement. There is no meaning in this arrangement. So children, that's why what happened? But to satisfy the properties, what happened? To satisfy the properties, even though argon is 40 and potassium is 39, according to his table, potassium should come first, argon should come next. But because of its properties, argon came first and potassium came next, which is against his law. His law says increasing, but he kept in this place decreasing, in this place also decreasing, in this place decreasing. Why? Because if you keep like this, properties won't satisfy. I can't keep all 40 kg students in 9th class, all 50 kg students in 10th class. Properties won't satisfy. Sometimes 40 kg fellow I have to keep in 10th class, 50 kg fellow I have to keep in 9th class. I can't say like that. If you say 13 years atomic, 8th class, 14 years, 9th class, 15 years, 10th class, means that's good. So in this confusion, at 3 places, inversion of atomic weights occurred. Means 40 came first, 39 came next, which is against his rule. His rule is increasing order, here decreasing order. Only in 3 cases it happened. Only in 3 cases. I hope everyone understood. If you have any doubts after recording it, I will clear your doubts. Please try to understand. Okay. Next, number 2. This is first in limitation. Second one, inversion of atomic weights occurred at some places. Isotopes did not find place in his table. Again, one more problem. Isotopes did not find place in his table. I hope you understood, children. I hope you understood. Isotopes. You studied in 9th class what is isotope, what are isotopes. Okay, what are isotopes, children? Elements having same atomic number but different mass number. Elements having, like suppose chlorine is there. 17 atomic number is correct only. One is 35, one is 37. According to his law, he should arrange elements in increasing order of weight. Means, imagine children, 2 boys came, both are 15 years only to your school. But one fellow is 50 kg, one fellow is 40 kg. Will you say You sit in 9th class, you sit in 10th class. Will you say like that? It looks awkward. Both are 15 years only. They should come, both of them should come to 10th class only. But because I arranged it in the form of weight, you sit in 9th class, you sit in 10th class. What is the meaning? Meaning what is it? Same way it happened for him also. Actually, chlorine 1717, you have to keep in one box only. You have to keep actually because they will have same properties. But because he arranged elements in increasing order of their weight, what happened unfortunately means where to keep these both elements he did not understand. He did not understand where to keep. Isotopes did not find place in his table. Where to keep two elements of same atomic number but different mass number, he did not understand. That is second disadvantage. Second, that only you should. That only you should. Third one, hydrogen did not find proper place. This is problem even today also, children. Hydrogen did not find proper place in his table. Not only in his table, children, even today it is kept separately. Why? Because reason you should know. In exam you should write reason. Why? Hydrogen did not find proper place means like metals, it give electron. Like metals, it give electron and form H plus. And non-metals, like non-metals, it take electrons and forms H minus. So where you place? Where you place? Well, along with metals or along with non-metals? No one understands. That's why even today, if you see children, modern periodic table, hydrogen is kept separately. It's not attached to anything. If you see modern periodic table, hydrogen is kept separately. Even today, it is confusion only. That's why hydrogen is kept separately. Okay, so these are the three famous limitations. If you have any doubts after the recording, I will tell you. Don't worry, children. So inversion of atomic weights occurred at some places. One, isotopes did not find place in this table. Two, hydrogen also did not find place in this table. Why? Means like metals, it can give electrons. Like non-metals, it can take electrons. These are the famous limitations. You should write first this only. Without this example, this point don't have any meaning, children. Without this example, I won't give marks also. Isotopes did not find place in this table. Hydrogen did not find place in this table. Reason also you should write. So this is how I told about law. Physical and chemical properties of the elements are periodic functions of their atomic weight. Characteristics. What are the characteristics I told children? 8 groups, 63 elements he arranged. 8 groups are there, children, and 6 periods are there. And he arranged elements in increasing order of their atomic weight. He kept elements having same formula of oxides and hydrides in one group. And what are the advantages? He left gaps for the elements to be discovered in the future. Eka boron, eka aluminium, eka silicon. And noble gases could find place in this table. He predicted the properties of elements based on their position. What are the disadvantages? 3 marks question. Only this they will ask some 3 marks question. Inversion of atomic weights occurred at some places. Which places? Argon, potassium, cobalt, nickel, tellurium, iodine. RK, Coney type. Remember like that, easy to remember in exam. RK, Coney type. Next, isotopes did not find place in this table. Hydrogen also did not find place in this table. Why? Because like metals, hydrogen will give electron, like non-metals take electron. Where to keep? Along with metals, along with non-metals, it was big confusion even today also. This is how Mendeleev's periodic table was made, children. Very, very important. 5 marks question may also come, 3 marks question may also come, or only law, only a boron, 1 mark, 2 mark. But this is the only theoretical question in this lesson. Remaining all are small definitions, etc., etc. Very, very important examination point of view. If anyone have any doubts now, you please ask me.